Okay guys, I've got a simple shop project here to work on for one of our viewers named Jeff. He's up in Saginaw, Michigan. Reached out to me and said that he's got a minor issue with a buffer that he wants to use and needs an adapter machine for it. So this is just a simple little sketch that he sent to me. He says don't really concern yourself with the dimensions he put on here, just make it whatever we feel is necessary. But basically what he's doing is adapting a metric thread that's on his buffer now to what would be a standard 5/8 buffer. He wants to be able to use these pads right here, which uses this, I'm sorry, that's the metric one right there. All right, that's the metric. He wants to be able to use these guys right here, which is a 5/8. So this is a standard size that anybody can go to any store and buy grinding discs, flap discs, anything like that with a 5/8 arbor hole. So we're just going to make up a simple adapter that's going to be drilled and tapped. So I already measured that. This is 10 millimeter by 1.5. So we'll have that side tapped for that. The other side, we'll thread it so that he can take these buffers right here, these buffing pads, and screw that onto it. And then we'll also mill a couple of wrench flats on there so he can easily take that thing and tighten it up on his buffer. Simple enough, pretty simple little job to do, and thought you guys might like to watch this and see this. We're going to use this piece of 1-inch 1144 stress proof free machining material, cuts nice, and it's nice and strong there too as well. So I think that'll work out just fine. So real simple machining ops. We'll do this on the manual lathe and then go over to the milling machine and mill a couple flats on it as well. So let's get this thing knocked out. We're going to use this piece of 1-inch to machine our threads, and then we'll go over to the mill and hold it in the indexing spacer to mill our flats before we cut it or part it off. But what I want to do is just go ahead and buff a little bit. Sometimes this material comes with this coating on there that kind of dries up. It's like a rust inhibitor from the factory where they make it, and it might throw your run out. It might throw it off a little bit is what I was saying. So sometimes what I want to do is just chuck it up and buff it with some emery paper. I just want to get that off there and make sure that we're chucking accurately on the natural OD of the piece of stock instead of clamping on that dried up oily coating that they put on there. And that's usually all it takes, is something like that right there. I think that should work. All right, so we'll give it a face and then we'll turn it back. We're just going to copy this right here, and I measured one of my grinders, it being the same thing. You got a 1/2-inch stick out there. So what we're going to do is just turn it down to this 5/8. I'll probably put a thread relief in there as well. And then we'll skin this OD so that everything is nice and true there with the thread also. Setting the DRO up there to 1/2 inch. Go ahead and do that now. Okay, now I got to change feed direction here. Yep, that looks pretty good. You see how nice that stress proof machines. It's really great material for a lot of different projects. You can buy that from McMaster Car. You guys are looking for some good machining material for your projects, check that out. 1144 stress proof. right, we need 26 thousandths. 10, 25, 6. I always turn my threaded features 5 thousandths undersize. And clean this face up. Go in there an extra 10 thousandths and then back face it here. And then while we're turning, let's go ahead and skin this OD just to kind of true it up. Let's see if 5 thousandths will clean this up. Tell you what, we're going to speed it up a little bit too. 1200. Yeah, there you go. I just touched it off and took 5 thousandths. Just so that the OD is running true with the thread. That's enough. All right, we're going to take this 1/8 wide radius tool right here, cut us a thread relief, and we'll take it down 1/8 of an inch. All right, there's our 0. Go in 100, 10, 25. All right, blend that corner in. Back out on our compound. All right, let me get a chamfering tool. Let's cut us a couple chamfers. Then break this corner too. All right, we are ready to thread. All right, first thing we'll do is go ahead and put some blue highlighter on here to make it so you guys can see it easy. Now we want to go ahead and get our tool touched off. We'll set me a 0 on the cross slide. 0, and we're going to run the compound up here and touch this guy. Alright, there we go. Now I'm going to set a 0 up here on the compound slide as well. So our thread depth is going to be approximately 68 thousandths. If you take your calculator and hit 0.75 divided by 11, 11 being our thread pitch, that gives you a readout of 0.068. That's your approximate thread depth using a compound slide set at 30 degrees or 29.5 degrees. I usually keep mine set right at 29.5 degrees. All right, so let's go ahead and I'm gonna reset the Z because I messed up. I don't want to beep it at me the whole time. It's gonna go right here. Let's go in for a scratch pass. I'm going to hit every other line so I'll know. So for threading, I'm going to use 1, 2, 3, or 4 on the thread dial on the lathe here. And let me get my pitch gauge and make sure that we're on 11. All right, we got our screw pitch gauge right here. We want to make sure that we're on the proper pitch on the machine, that we've got our gearbox set properly. So that looks like it's good. It's lining up on 11. So we should be good to go. It would help if I bring the cross slide back to a 0 before I do that. All right, here we go. Just taking about 10 thousandths to pass. Should be 40. Really don't need any cutting oil on that. It definitely helps, but it's not really necessary if you don't want to use it. That stretch screw is pretty easy machining stuff, free machining. Didn't even take the depth on that one there, so try that again. This would be 60. Now we should have some material still to go here, but I'm just gonna use this for right now. It's a factory made flange nut, Tico brand, and this should give us a really good indication of our fit right there. Go back in and make another pass. That's getting close right there. All right, what I'm gonna do is just kind of sneak up on it here, and then once I feel like I'm close, I'll go ahead and measure the pitch diameter and see where we're at. Let's take another thou because it's still tight. Guys, keep in mind that if you guys are doing this for your own personal projects, you don't always have to fuss with proper pitch diameter and being exactly on specifications for industry. If you're just making parts that you're just putting together yourself, or you know you're going to fit them together, don't really worry about all that. Just make sure everything fits properly. You don't want it tight, you don't want it loose, you know. Let's take another thou because that was still tight right there. Missed my number. This should be putting us really close right here. All right, that's got a really nice fit, a tighter fit than what you would probably find on most hardware. So now we'll go ahead and measure our pitch diameter. All right, I'm going to use my thread triangles here to measure this. And I'm looking for a basic pitch diameter for 5/8 11, measuring, I'm going to say between 0.881 and 883 is ideally what I'm looking for here. Just got to make sure you get everything squared up nicely. Rotate it there, rock it, pull it off. Where am I at? I am at 92. So it's still like 10 thousandths over what we want. So I'm going to use my thread triangles right here, measure over the thread pitch here using our 1-inch micrometer, and what I'm going to be shooting for is a basic pitch diameter of, I got to look at the calculator again. I done forgot what it was now. Look behind me. 0.887. 0.887 is what I'm hunting for. That'll give me a class 4 fit if I measure it correctly. And we are at 892. So I still need about 5 thousandths off of that. So, I mean, that's, right now we got it at a machinist fit. So it's got a really, really close fit there. So you do need a little bit of clearance there, because the part that's going to be screwed on there may be machined or made to a different tolerance. So let's go ahead and let's take another couple little one thou passes on this. All right. Maybe that'll get us a little bit closer right there. What what I find to be kind of helpful when doing these or using these triangles is if you, they are tricky. It takes a little bit of practice to get used to them, but if you kind of squeeze them together on the back side of the part and then bring your mic in to the center, the mic, you got to use the mic to kind of hold the triangles in place right there. All right, and I am at 888 on our pitch diameter. I think I'm just going to leave it right there because it's got a good fit on that 5/8 11 flange nut there. And let's take our piece that's actually going to be screwing on there, which is this guy right here. He says this is the pads that he buys off of Amazon. And let's see how it fits. Look at that. See, it's got still got a little bit of rock there. You can screw it in. It's just going to be hand tightened like that. I think we're going to leave our pitch diameter just where it's at. This kind of goes into what I was just saying, is that you don't always have to worry about what the industry size is supposed to be on things. You know, you can get it really, really close and just kind of hand fit things. And you know that if you get it really close to that spec, it's probably going to work out just fine. So I feel confident that our pitch diameter is going to be perfect for these El Cheapo pads that are probably made overseas somewhere. You know, that's some of that pigment that stuck to it. I can feel a little bit of slack in the thread, so it's not tight. I think it'll be just fine right there. Now I want to polish that thread a little bit. It's got a little bit of rough feel to it. Just going to use a little bit of emery paper. Polish it up. Now let's hit that outside, kind of brighten it up a little bit better too. All right, so that part is done. Should be good to go. So what we're going to do from here, instead of parting it off now or cutting it off, I want to be able to have some material to hold it, just like we're doing here in the lathe. We'll leave this on there. We'll go to the milling machine, chuck it up in the spacer. We'll mill the two flats, and then we'll either cut or part it off after that's finished up. Okay, we got our indexing spacer set up here on the KBC mill. I decided I'm going to make this area of the adapter 3/4 inches long. So I just want to find the center of that being 3/8. We'll use an edge finder for that. And then we're going to use a 3/8 diameter end mill just to mill a couple flats on there for a 5/8 wrench. All right, we got our 3/8 2-flute end mill loaded up. Let's go ahead and let's measure what the OD is and calculate what our depth's going to be. All right, so let's call that 0.990. Took about 10 thou off the OD. 0.990 minus 0.625 for our 5/8 width divided by 2 equals 0.1825 is what we'll take off each side. So we'll touch off, take 182, and that should land us on our 5/8 width there, or flat that we want for our wrench. Go ahead and get our touch off set. All right, there we go. Probably took about a thou right there. And we'll bring it up our 182 thousandths. Rotate at 180. Come back for another cut. Try our 5/8 wrench. Fitting on there just like it should. I chose to use the 5/8 wrench flats because that's what he had put on the print. He said either 1/2 or 5/8, so I thought the bigger the better there for that 1 inch. That's going to work out fine just like that. All right, let's go ahead and let me find my T-handle. Where I put the chuck wrench? So it's right here, right where it's supposed to be. All right. I think what we'll probably do is just go back to the lathe. We need to do some deburr and get rid of those sharp edges where we just milled it. But we'll go to the lathe and just part this guy off, and then we should be able to flip it around, chuck it like that, face it, drill and tap it for our metric thread. Be a little bit easier to go ahead and deburr that with a file with this extra shank on there. So I'll go ahead and work on that now before we part it off. I realize there's a tool that I don't have in the shop I need to go ahead and get for the box. That is a small set of files. This is the smallest file I got, and I need to go ahead and get some of those small, like little jeweler's files in the box. I hadn't even thought about that until just now. That's good. All right, so our part's going to be 3/4 of an inch long, plus I'll face it off a little bit, so I don't know, we'll go about 30 thou past that, like so. I'm going to get her parted off. Go ahead and set a Z0 in case I have to move it. See how this sounds. Just feeding it by hand, by the way. Doing pretty good. There you go. Boy, that is handy, isn't it? So this is still a good little piece of stress proof left over that I'm going to put in the toolbox here. We can use for another project, but it's important that you mark it because as soon as you set that in a box, you're going to forget all about it. You'll have no idea what kind of material it is. I could take a good guess of what it is because I remember what I put in there, but I just like to do this. So I'll put an SP for stress proof like that. So just mark your drops there so you always remember what they are. All right, so there's our piece. We need to face it off. Looks like we got it 800 thousandths wide, so we need to take 50 thousandths off that side. Oh yeah. Get rid of that little nub on the end first. All right. Take 40 thou and then measure it. This is not a critical dimension, it's just a target dimension. And you want it to look kind of uniform too, you know? Let's take 10 thou. Let's go ahead and chamfer it. I got this kind of tool set up for getting chamfers done nice and easy, especially up next to the chuck. Brazed on tool. Okay, all right, now we just got to drill it and tap it. All right, this is the thread that we need to drill and tap right here, 10 by 1.5. Let's find us a set of 10 millimeter. There we go, 10 by 1.5. We use those, and then this tap wrench right here will probably work. And we need our tap drill, which should be 8.5 millimeter. 8.5 right there. 8.5. All right, so all we got left to do is tap. I'm going to use Anchor Lube for our thread coating lubricant right here. I really enjoy using this stuff. It works great. I really highly recommend it. I'm just going to take the tap and just dunk it in there just like so. I've got a spring-loaded center loaded up in the drill chuck here. All right, there we go. There's the bottom. Looks like we've got some nice looking threads in there. All right, and there's the adapter or the thread that's going to be on the grinder that this is going to screw onto. And it feels like we actually have a very close fitting thread right there. Let me get a little wrench and make sure that's going to screw in there. That's actually a really nice fit. So like I said, this isn't what is going to be going on there. It's just the thread itself. I think that's going to work. This job is pretty much finished up now. All right, guys, well, this is going to wrap up this little shop project. This was a relatively simple little part to make with some of your basic tools in a machine shop there. This is everything that we used, minus the end mill, the index spacer, mill and machine. You got your lathe over there, but anybody that's got a lathe and a mill and some of the stuff in your shop, you can easily make little parts like this. And I think Jeff is going to be happy with this, and he can finally get this put on his buffer, and he can start using this pad right here. So again, this is how to work. This is what he wanted to be able to put on his buffer. So that will screw on to the adapter like so. And then this is going to be the thread that is on the buffer right here. And then we've got our wrench flats there so that you can use that to tighten it up and take it off of the buffer. So very simple little shop project. And I wanted to capture that. I know you guys like watching this kind of stuff, using all of your basic tools, your basic measuring tools, some cutting tools and taps and things like that with your lathe and the mill. So I'm gonna get this guy boxed up and get it sent up there to Jeff. He's been patiently waiting on this, and I finally got it done for him. And I hope you guys enjoyed watching, and I hope to see you again on the next shop project. I'm getting the swivel plate mounted up here on the manual mill, so I'm going to come in there with our face mill and clean up all these ears. This is going to be a really simple setup. I've got my fixture indicated now, got that indicated in the middle, and this was one of the old swivel bolts, one of the bad swivel bolts that didn't have good threads on it. One of my test pieces, should I say. I just cut the threads off, faced it, drilled it, counterbored it so that we could bolt it down to the table. This is going to be our pivot point right there. So now that we've got it centered up, got our DRO centered up there, we'll be able to slide this down onto that pivot boss, and then we'll just use some clamps to hold it down, and we'll be able to just line up our ears sort of in the middle of that slot like that, and then come in there and just clean it up. It's nothing high accuracy, so once we get in the center of that boss right there, we should be able to just kind of line this up in the middle visually and run our face mill in there until it just cleans it up. I got the swivel base set up. We're ready to start doing some machining. So one toe clamp there on this ear, and then that one to support this side, and you can see that we got enough clearance with that 2.5 inch face mill that we can get in there and make that cut. So I don't know how much we're going to be taking off. We'll start cleaning one of them up nicely, and then we'll pivot it around and just take the same amount off each one of them. If one of them happens to be lower than the rest, then we'll just clean it up, maybe clean it up separately, but I don't see them being too off on the thickness there. All right, let's get to cutting. I established a contact point there, kind of leveled it out. I can actually see the casting there, the tops of the rough casting where I touched it. I set a 0 in our X axis also, and we brought it up 40 thousandths. Got to go the right way. That's the right way. Bring it in here to my 0. Almost, not quite. I wonder if another 10 will get it. That looks good though. Let's go up another 10, so that'll make 50. Nearly got it. Definitely looks a lot better. I wish that it didn't grind so heavy on that corner of that ear. Got to make a decision on what to do there. You know what I mean? I think we'll take 10 more, so that's a total of 60 thousandths, because the other ones have some grind marks on them as well, and it may not clean them up. I'd like to kind of keep it consistent on height. So let's just do another 10 thou. It's not going to kill anything. Yeah, that just about cleaned all that grind mark up there. We get down to our 0, I'll drop the knee down so that we don't drag on the way back. Yeah, that looks pretty good. I'm going to bring this back up to 60. Maybe we'll do that in 2 cuts on the other ones. And there we have it. That looks nice. All right, we'll rotate it around, do another one. That one's going to have to come up and out of the way every rotation here. I didn't think about that, but I don't have any more room. We'll just have to take that one off and move the stud out of the way. So honestly, all I'm doing is I'm looking down there. Now it's up high where I can't see it as well. But I'm just looking down through the hole and making it equal on the mill table there. Like that guy right there. But I'll check this one and make sure that it's lined up, and then we'll clamp it down. We're using our brass shims there against the table. Just about had it perfect. As perfect as that casted hole is anyway. That looks pretty well equal right there. Get one side, get this side kind of pulled down and make sure I haven't moved it out of place. That looks pretty good. I think we're right on it. Flange nuts, just sometimes on these studs, it just never wants to start straight. Okay, we got that finished up. All 4 ears are now machined. So 60 thousandths was kind of the magic number there. It could have stood for at least another 5, possibly. You can see the very edge of it right there on all 4 of them are still just slightly touched with that grinder. But we got them all cleaned up nice and flat. That's the main thing. We know that this surface is now going to be parallel with the bottom surface there, and it just looks more presentable that way. It looks a little more finished. And I'm still planning on machining some stainless steel washers that we'll use with our stainless hardware for the final bolting of these things. So it'll look pretty good with that stainless steel shop-made flat washer on top of that. All right, so this right here is now finished up. I think we've got most of our little side projects finished off with our hardtail vise. So we can move on to the final machining, which is going to be the inside portion of the main vise body.